Hi guys, my name is Jennifer Steele. I'm a faculty member at American University and I'm the course developer of EDU 610, Overview of Qualitative and Quantitative Research Strategies. So today I'm going to walk you through how to do Topic 5 Excel assignment, which focuses on value labels, conditional means, standard deviations, and standardized mean differences. If you're watching this in fall of 2019, you might have completed a version that did not include standard deviations and standardized mean differences. So you might want to pay particular attention to the second part of the video that does focus on those two skills in particular. So you should be able to see my screen, and we will start by downloading the data, which is a data set of 200 students from the high school and beyond data set. And this is a data set of students who were in high school. I believe they were 10th graders in the year 1980. So these data are quite old. And what we have on the assignment is it describes the variables in the data set, which include this anonymous student ID, whether the student is female or male, coded 0 for male, 1 for female. There's a race ethnicity code indicator, 1 for Hispanic, 2 for Asian, 3 for African American, 4 for white. Socioeconomic status indicator, school type indicator, 1 for public, 2 for private. That's important because we're going to use that in this assignment. Whether they're in a general academic or vocational program. Their reading scores with a range of 28 to 76, their writing scores with a range of 31 to 67, and their math scores with a range of 33 to 75. And these are scores on a 10th grade standardized test. And we also have science and social studies scores. And so the meanings of these scores are somewhat arbitrary. You shouldn't think of them as percentages correct. They're just scale scores on the test that was used on this particular high school student survey. And then we have a variable called FEM labeled, which is a text variable, a string variable. String variables are text variables, which is a labeled version of the numeric female indicator. So female, we said, was coded 1 for female, 0 for male. And so we've just created a text version of that already, which is called FEM label. So one of the things that you're going to do in this assignment is learn how to create a text label of the same sort. So going to page 2 of the assignment, the first thing that we're going to do is create this label variable called school labeled, which will be a text version of the numeric variable SCHTYP, or school type, which we said before is coded 2 for private school, 1 for public school. Okay, so this tells us what kind of schools the high school students are currently attending. So to do this, we're going to look at the data set, and the data sets are accessible within Canvas where it says downloaded here. You can download the data set. And when you do that, you'll have an Excel spreadsheet that looks roughly like this. So you've got your variables ID, female, race, socioeconomic status, school type. Horizontally, the top row of your spreadsheet are the variable names, and then all of the data start from row 2 downward. So the students have these anonymous IDs, ID numbers, which range from 1 to 200. And then we have all of the data about each of these students in the subsequent cells. So in Excel, you have columns which are labeled A, B, C, D, E, F, G, etc. And you have rows which are numbered. And then we have the data in the cells, and the cells are indicated by the row that they're in and the column that they're in. So for example, this cell right here is cell A2, which you can tell by looking here that I've just clicked on this cell, which is in column A, row 2, and we're going to refer to that in all of our programming as cell A2, which means that this social studies score for student ID number 1 would be in cell K2. And so that student's score on the social studies assessment was 41. And again, we find that in cell K2. So that's the way that Excel works. It's just rows and columns, and nomenclature of the cells reflects the column location and the row location. So the way that the FEM labeled variable was created is with this line of code right here. So if we click, whoops, let's undo that. If we click in column L, row 2, we see that the variable is, we see the word female, but when we click it, there's actually a code here. There's a line of programming code, because when we're working in Excel, we're actually becoming computer programmers. So the line of code that we use to get that word female to show up there is we used an if statement. So anytime we write a line of code or programming in Excel, we start it with an equal sign. So in this case, equals, and then we have an if statement. If B2, cell B2, equals 0, comma, we want it to display the word male, which we put in quotes, comma, and then we have another if statement embedded within the first if statement. If parentheses B2 equals, if parentheses B2 equals 1, comma, we want the word to display female, and we put that in quotes. Then we follow that with a comma because there's no alternative. We're not giving Excel an alternative for what to do if it's neither 0 nor 1. So that's why we have a comma with nothing following it. We follow that with a close parentheses for the second set of parentheses, and then a close parentheses for the first set of parentheses. And notice that Excel codes these, assigns color codes to the parentheses when we're up here in the command line. So we see that the inner set of parentheses are colored in red, just to help us keep track of which parentheses go with which ones. And this outer set of parentheses are colored black. So we make sure that we've closed both sets of parentheses, and then that's how this code works. So we click OK or enter, and we go to the next cell. And what we've done is we've basically put in this line of instructional code in the first row in L1. And then the way that we created this in the first place is we dragged that command downward. So we clicked on the cell, and when we click on the cell, you see that there's this green box around the cell, and you see that at the bottom right corner of the green box, there's a little green square. And that little green square, we can just grab that green square with our cursor and drag it downward, and it drags whatever we put in the top cell, it drags it down for the whole thing. So it now applies that code, that instructional command, to every row of the 200 rows of data. And that's why some of them say female. If female is 1 over here, it says female over here. And if female is 0 over here, it says male over here. So these should now, column L should now be a text version of all of the information that's in column B. And that's how we've created originally a labeled version of the female variable. So now for the first step of your assignment in step 1 of the Excel assignment, it says in column M, create a variable called school labeled, which is a labeled text version of the numeric variable school type. So we're going to follow the same thing that we just did. The same exact logic that I just showed you for female is what we're going to do for school labeled. Let me just go back and double check. Okay, we want this to be called SCH labeled. And so we're going to give it a name at the top of column M, SCH labeled. Okay, we just type that into the cell. And then now, because we're typing a formula, we're going to type equals and then if. We have our if statement. And so it tells you right here, it pops up the syntax of if. So if logical text, comma, value if true, comma, value if false, close parentheses. So that's the syntax of the if formula. So we're going to say if, and we're doing this for school type. And remember, school type 1 is public, 2 is private. So if SCH, oh wait, no, we don't want that. We want if E2, because right now we're working in row 2, if E2 equals, E2 equals 1, comma, public, and then if E2 is not equal 1, we have to tell it what to do. Oh wait, we forgot to put that in quotations because it's text. Okay, we put it in quotations and then we put the comma after or outside of the quotation marks because the comma is not part of what we want to display. What goes in quotation marks is only what you want to display. So if E2 equals 1, comma, public in quotes, and then we have to tell it what to do if E2 is not 1. So that's where we put our second if statement in this case. So we're gonna, if E2 is not 1, we need it to do something else, and that something else in this case is also based on an if. If E2 equals 2, comma, private, put that in quotes, comma after quotes, and there's no other option. It's always going to be either 1 or 2. So we're going to close those parentheses, and then we're going to close the outer set of parentheses. And if we haven't made any mistakes in the formula code, then this is going to work. So then I just hit enter and voila, it worked. So because school type is 1, the text that was displayed here is public. Now we're going to click that little green box at the bottom of the cell, and we're just going to drag it down until we get to the end of the data. And that is like that. Okay, now this worked because notice that starting at row 175, all of the schools are now private. School type is 2 starting at row 175, which is for student 174 and on. So this school type is 2 starting from that point on, and sure enough, starting from that point on, all of the data say private, and before that, all of the data say, oh, public, except there are a few exceptions. It's not really perfectly sorted on public-private. So for example, row 32 is private, and that is correctly noted under school labeled. And same thing for rows 35 and 36. Yeah, so we've double checked our work and we've checked that our labeling is correct, and voila, you now have a text-based variable to correspond to which was previously just a numeric variable. So what we've just done is we've basically created labels for the values of the school type variable, and that's just for ease of it's to make the data easier to read and understand. We can now work with either version of that variable that we want to. Okay, let's go back to our assignment. The next step of the assignment, step 2, is to calculate the mean scores for reading and math, calculate mean reading and math scores. And we're going to do this in cells G202 and I202 because those are the reading and math columns. So we're going to find the mean reading score from G2 to G201, you will use the formula equals average G2 colon G201 in parentheses. Or you can just type average with your equals average with your open parentheses and then click and drag the numbers with your mouse and then close the parentheses. So we'll do this for both reading and math. And then we're going to type the word mean in F202 just so that we know that what those numbers represent. Okay, so to do this, we need to scroll down And we're scrolling. And by the way, the reason that row one is not moving as we scroll down is because when we created this spreadsheet, we created a freeze frame for the top row. And the way that we do that is freeze panes on the view menu of Excel. But I'm not going to show you that right now. But that's why row one is staying put as we scroll down the rest of the data. Okay, so we go down here to the bottom of our data and we're in row 202 as instructed. And I'm going to go ahead and type F202. I'm going to go ahead and type means in cell F202 as instructed. Just the word mean in F202. And then I'm going to follow the instructions by typing equals. So in G202, I want to calculate the mean reading score. So I'm going to type equals G2 typing equals average, parentheses, G2 colon G201. And what that says to Excel is it says, I want the average of the array of numbers that starts in G2, which is our first line of data, and goes all the way down to G201, which is the end of our data. And then I close parentheses, and sure enough, it gives me a mean of 52.2. Now, if yours is not rounding off like this, you can tell Excel how much rounding to do with with your number formatting options on the home screen. I'm going to just have it default round to one decimal place, one place after the decimal, but do whatever you like. Okay, so then we're going to do the same thing for math, and this time I'm going to do it slightly the other way. So equals average, open parentheses, and then I'm going to click and drag the array that I want, which is I2 to I202. And then I'm going to come up here to my formula bar and just close the parentheses after I clicked and dragged. And it works the same. Now we have the average of I2 to I201. And that average is 52.6. Average for reading is 52.2. Okay. So we've just calculated the mean scores in reading and math. And by the way, if we wanted to do the same thing in writing, which is right in between them, we would just take the cell and take the green square at the bottom and just drag it. And it would just drag that formula and apply the same formula to column H. So that's a fast and easy way to expand your formulas to the other columns or rows if you want to. But the ones that we care most about here are math and reading. So I'm just going to bold those so that you can see them more easily. Okay, now we're going to do what's called a conditional mean in reading and math. We're going to calculate the mean just for private schools and the mean just for public schools. And so for this, the formula is a little bit more complicated and it involves some dollar signs. So we're going to type in cell G203, so we're going down to the next line of data, we're going to type average if S, average IFS, and then we're going to put in that we want the average of G2 to G201 if, so comma, E2 to E201 is equal to 1. So that's what the logic is indicating here in this formula. And notice also that we have some dollar signs in here. The dollar signs are here so that as we change the dollar signs preceding the numbers mean that the numbers don't change as we drag the formula downward. So normally when you saw me clicking and dragging formulas with the little green square, they update to whatever row or column we're dragging them to. But if we don't want them to change as we drag formulas up or down, if we don't want the rows to change, then we put a dollar sign before the numbers. And that way, and in this case, actually with E, we're also putting a dollar sign before the columns as well. And that means that as we click and drag these formulas, the column will not change in the case of the E's, and the rows will not change in the case of both the G's and the E's. And the logic here again is that we want the average of the G's if the E's, the corresponding E's are equal to 1. That's the logic, because the logic is average ifs range, comma, criteria range, comma, criteria. And then we'll do the same thing for math, but we'll change the G's to I's. Okay, and we're gonna label these public means and public mean and private mean in F203 and F204 respectively. Okay, so coming down to F203, we're going to put public mean and private mean. So we're getting mean scores for public schools and for kids in private schools among these 200 10th graders. Okay, so the syntax is average IFS parentheses G $2 colon G $201 comma $E $2 colon $E $201. And because we're focusing on public schools, the criteria number is 1. We want the average of all of the reading scores if the corresponding school type is 1, and that's a conditional mean just for public schools. Okay, so now the conditional mean for public schools is calculated at 51.8. And the reason, now you're gonna see why we use the dollar signs. We're gonna take that little green square, we're gonna drag it down to private mean to the next row. And so far it looks exactly the same. It's still 51.8. But if we come up here and in the formula bar, we just edit this so that it's now the average of all the reading scores if school type equals 2. So we're going to take that criteria of 1 and change it to a 2. And now we have a private school mean of 54.3 and a public school mean of 51.8. So now we've calculated conditional means in reading for public and private. And we're going to do the same thing for math. We're just going to take both cells. We're going to click and drag at the bottom and drag these over to math, which is column I. I'm going to get rid of writing just because I don't want to confuse us. Okay. In fact, I'm going to get rid of writing in, whoops. I'm going to get rid of those other means because I don't want to confuse us. Okay. So I've dragged the formula over here to math, and let me see if it's correct. Let's go up here and say, okay, it looks like it updated correctly because the thing that we're averaging is math, and all of that is in column I. So column I did update. We're no longer in G in our formula, we're now in I, but our reference category is still school type. So just like we were hoping, just like we intended, the reference columns did not change. The reference column did not change. It's still E because we have the dollar signs in front of the E. And we're looking for the scores for public schools, conditional means for public schools because our criteria is 1. So voila, that worked. And then finally, private school means, looks like that one also updated correctly. We've got private school means for math scores if school type is 2. So that's correct. So now average math score in public schools is 52.2. Average in private schools is 54.8. So we have now completed step 3. And now we're going to move on to standard deviations. So if you're watching this in fall 2019 in an online course, you would not necessarily have done this in your homework. So this is where you want to pay particular attention, because standard deviation, you can calculate that in Excel in about 10 seconds flat just by typing in the formula for standard deviation, but instead we're going to do it manually by hand so you understand conceptually what a standard deviation is. And you may remember from your live session that The formula for standard deviation is, let me just drag this to the screen so you can see it, that the formula for standard deviation is the sum of the difference of everybody's score minus the mean score. You add up, you square those differences and you add up all of those squared differences and you divide by the total number of observations minus 1. That's the standard deviation for a sample set of numbers. The square root. If you don't take the square root, it's a variance. Once you take the square root, it is a standard deviation. And standard deviation is therefore interpreted as the average difference in absolute value of every person in the sample from the sample mean. It's the average distance of everyone's average distance from the mean of the sample. So if people are very scattered, then in their attributes, then the average difference is going to be large. If everybody is very homogeneous with respect to whatever the number is, whatever is being measured, then the standard deviation is going to be small. Everybody's going to be quite close to the mean. Okay, so a standard deviation is a way of describing how much variability there is in a data set, in a measure. Okay, so to calculate the standard deviation manually, understanding that it really is the mean of all the squared deviations from the mean, we're going to do this in step 4. So, so in column N, we're going to create a variable called readDev, R-E-A-D-D-E-V, which is reading deviation. And we're going to put that in N1. And it's going to be defined as in N2, it's going to be G2 minus G $202, which is the deviation of person 1 in G2 from the mean of everybody's reading score, which you'll remember is in G202 right here. So we're going to type over here, we're going to type readDev, and did I put that in the right place? Yeah. And so in N2, we're going to type G2 equals G2 minus G $202. And then we're going to drag this down for rows 2 through 201. And then we're going to square. So then we've got everybody's squared standard deviation from the mean, or everybody's deviation from the mean. Then we've got to square those, which we'll do in column O. So in column O, we're going to create a variable called read squared dev. Read SQDEV, which is the squared deviation of the individual's reading score from the mean. And then we're going to do that by entering the formula equals N2 caret 2. And the caret is just above the 6 on your keyboard. So you just have to do shift 6 and you'll get caret. So we're telling Excel to take the values in N2 and square them, raise them to the second power, which is squaring them. Then we'll drag that formula down, and then we've got everybody's squared deviation. Then we're going to calculate the variance, which is we'll calculate the sum of the squared deviations in N202, and we will then divide that by N minus 1, and we will label that variance in N203. And then we will calculate the square root of that variance in N204, which uses the square root formula. Okay, so we're just going to be doing a little bit of math here. So for reading deviation, we want the deviation of person 1's reading score from the mean reading score. Person 1 got a 34 in reading, and the mean reading score for everybody was 52.2. So that person has a negative deviation because it's going to be 34 minus 52.2, which is going to be about negative 18. I guess it's going to be negative 18.2. Let's see if I'm right. Equals G2 minus G $202. Yep, negative 18.2. Yep. And so now I've got that person's deviation from the mean, and I want everybody's deviation from the mean. So I just take my little green square and drag my formula down to the bottom of the data, which is in row 201. Okay, now I've got everybody's deviation from the mean. Okay, now I want to square those deviations according to the formula for standard deviation. So READ SQDEV, and I'm going to go equals this deviation raised to the power of 2. So it's equals N2 raised to the power of 2, caret 2 raised to the power of 2, which is squared. Okay, now I'm going to take those squared deviations and just drag that down so that everybody has a squared deviation of their score from the mean. And I'm going to round those off with this little button up here. Okay, then we're going to sum all of those squared deviations. And we're going to do that in cell N202. Okay, yeah, O202, that's what we're doing. Okay, so down here in O202, we're going to take the sum, which is equals sum, and it's the sum of this entire array, reading squared deviations. So it's O2 through O201. And we're going to label that sum of square deviations. And then we're going to calculate the variance in the next row as that sum of squares that we just calculated, O202, divided by 199. And because we have 200 people in the data set, and we're dividing by n minus 1. So it's going to be, we're going to call that the variance. And it's going to be this sum of squares that we just calculated divided by 199. And we get 105. So now we've got the variance. And you will likely remember that the square root of the variance, the square root of the variance is the standard deviation. So we're going to calculate equals square root of O203, and that will be our standard deviation of reading. We'll do that in O204. So equal square root of parentheses O203. Okay, and it comes out to 10.25294, which we can round to about 10.25. And that's going to be our SD standard deviation in reading. Okay, now we can check our work by, let's see, we can check our work by just typing in equals standard deviation for the column of reading. So equals standard deviation of G2 to G201. And in some versions of Excel, it's stdev.s. And in older versions of Excel, it's stdev. So I can't even remember which one it is in this version. So I'm going to type in stdev. And it looks like I have a newer version of Excel, so it's telling me that the current version is stdev.s, which is standard deviation of a sample. And so I'm going to type in that I want the standard deviation of O2 to O201. This is the shortcut way of doing standard deviation. Oops, that doesn't look right. Oh no, sorry, it's G2 to G201 that I want. Sorry about that. And good job if you caught my mistake before I did. So we want the standard deviation of reading scores, which is G2 to G201. And sure enough, it is 10.25294, just like what we calculated by hand. So we're going to also label that SD read because it's the same thing. So we've just checked our work and confirmed that we got the same answer, which is great. Okay, so now we want to calculate the standardized mean difference in reading scores for public schools versus private schools. And all that is it's a difference in the means of public schools minus private schools divided by the standard deviation, the combined standard deviation for everybody. So in cell G205, we're going to just find the mean difference, between the difference in means. Okay. So this is going to be mean. And it's going to be equals, oh wait, what are we doing? Public first. So it's going to be the difference between public school and private school. So we're going to do 203 minus 204. So it's going to be public minus private. Okay. So public minus private is going to be equals G203 minus G204. And the difference is negative 2.4. That means that on average, public school kids in reading scored 2.4 points below private school kids among these 210th graders from 1980. So the public school kids did a little bit worse on average. We're going to take that same formula and just drag it over here to math so that we also have this done in math. And in math, it's negative 2.5. Let's see, and label this as math. Okay, so then to decide if this is 2.4 points is a large or small difference, we're going to divide it by the combined standard deviation of all the kids in reading, which we already calculated over here. The standard deviation in reading, we said, is 10.25. So we're going to take this mean difference and we're going to call this the standardized mean difference for public versus private. And it's basically that G205 that we just did divided by O205, which is the mean difference in reading. I mean, the standard deviation of reading. And so we're going to type that in cell G206, and it's going to tell us that public school students scored 23% of a standard deviation lower than private school students on average in the data set, because our standard deviation in reading is about 10 and the mean difference is negative 2.4. And so 2.4 is almost a quarter of 10. So that's what it's going to tell us. So this is going to be called standardized mean diff pub v priv. Okay, and it's going to be equals the mean difference divided by the standard deviation. Oh, it's rounding to negative 0.2, but if I let it show a couple more, 2 places past the decimal, it's negative 2.23. So it's almost a quarter of a standard deviation worse that the public school kids did relative to the private school. Now, is that large or small? You're going to learn later in the course that a difference of a quarter of a standard deviation is, in education terms, a pretty noteworthy difference. It's a notable and meaningful difference. A 1 standard deviation difference in social sciences is very large. So a quarter of a standard deviation is usually considered pretty meaningful. And then finally, step 6 tells us to do the same thing for math that we just did for reading. And to do that, first we need to get the standard deviation in math, which, let's see. So let's do standard deviation of readings of math scores over here in O206. So we'll just do equals standard, we'll do this the short way, standard deviation dot S for the math scores. and it's 9.37. We'll label that SD math. And we'll come over here to math, and we're going to calculate the standardized mean difference, which is going to be the mean difference in I-205 divided by the standard deviation of math scores in O-206. And the answer, I'll give that an extra. The answer is that in math, the public school kids scored about 27% of a standard deviation, so 0.27 standard deviations lower than private school kids. So in both cases, the public school kids performed somewhat worse by about just under a quarter of a standard deviation in reading and just over a quarter of a standard deviation in math. And so I've just bolded those to make them more clear. And we have now finished the assignment. So you're going to save this with your last name underscore topic 5, and then you're going to upload your file to the file submission area. So file, save as, you just type in your last name underscore assignment 5, save it, and upload it, and then you are finished with topic 5. If you are watching this in the online courses in fall 2019 and you only did the conditional means because that's what the assignment said for fall 2019, you don't have to go back and do the standard deviations. You can if you want to, just for practice so that you learn the skill. But the most important thing is just that you understand conceptually what a standard deviation is and what a standardized mean difference is, in addition to means and conditional means. So hope you enjoyed this video. Please feel free to go back and rewatch whatever parts you need help with, either on this assignment or as you do subsequent assignments. And good luck with the rest of your Excel adventures.